एंड वेलकम बैक। हमारा चल रहा था अलजेब्रा ऑफ मैट्रिसेस। लास्ट वीडियो में हमने स्टार्ट किया है अलजेब्रा ऑफ मैट्रिसेस। ओके, उसमें हम एडिशन देख चुके हैं, सब्ट्रैक्शन देख चुके हैं, एडिशन की प्रॉपर्टीज देख चुके हैं। अब हमारे पास है मल्टीप्लिकेशन, अलजेब्रा ऑफ कॉम्प्लेक्स नंबर, राइट? सो मल्टीप्लिकेशन ऑफ कॉम्प्लेक्स नंबर्स. So suppose you have two complex numbers Z1 which is A1 plus IB1, Z2 which is A2 plus IB2. So what we have to find is what is Z1 into Z2. Okay, so Z1 into Z2 is equal to A1 A2 minus B1 B2 plus I times A1 B2 plus A2 B1. Okay, if you want you can verify the formula. Verification is very simple. Okay, just put the values of Z1 and Z2, A1 plus IB1 into A2 plus IB2, right? So then just multiply. So A1 into A2 plus I B1 A2 plus I A1 B2 plus I square B1 B2. This gives A1 A2 plus I A2 B1 plus I A1 B2 minus 1 in B1 into B2. Why minus 1? Because I square is minus 1. So this becomes A1 A2 minus B1 B2 and take I common from here and you get this. Okay, so verification is very simple. Suppose let us take an example that Z1 is equal to 2 plus 3i. Z2 is equal to 4 plus 6i. Then we have to find what is Z1 into Z2. What is Z1 into Z2? तो हमें क्या देखना है, देखिए A1 की वैल्यू है 2, A2 की वैल्यू है 4, B1 की वैल्यू है 3, B2 की वैल्यू है 6. हमें क्या करना है, बस ये फॉर्मूला अप्लाई करना है. A1 into A2, A1 into A2 8 minus B1 into B2 3 into 6 18 plus I times A1 into B2, A1 into B2 2 6 12 plus A2 into B1, A2 into B1 3 4 12. So this gives you minus 10 plus I times 24, which is minus 10 plus 24I. So this is the answer. So you have seen that it is very simple to find multiplication of two complex number. What you have to do is just calculate using this formula. And how we get this formula? I have given the proof. Okay. So now let us look at what are the properties of multiplication. हमने एडिशन की प्रॉपर्टीज देखी, राइट? एडिशन की प्रॉपर्टीज associative, commutative, existence of identity, existence of inverse. So वैसे ही multiplication, the same properties we'll see in multiplication. Okay, associative, commutative, existence of multiplicative inverse and existence of multiplicative identity, and many more. So let's have a look. Okay, so first property we have commutative. Second we have associative. Third we have existence of multiplicative identity. Okay, multiplicative identity. And then same for inverse. Okay, multiplicative inverse. Then fifth we will see distribution, or I can say distributive property. And another we'll see that is what should I say, after distributive we will see what is the division of complex numbers. What is the division of Z? How we divide Z? How can we divide Z? Let's start and get this complete fast and fast. So suppose Z1 is equal to A1 plus IB1, Z2 is equal to A2 plus IB2, and Z is equal to A plus IB, and Z3 is equal to A3 plus IB. Sorry, you cannot see a word, so I'll write it down. So put Z1 is equal to A1 plus IB1, Z2 is equal to A2 plus IB2, Z3 is equal to A3 plus IB3, and Z is equal to A plus IB. Okay, we take these. So first is commutative. Commutative means Z1 into Z2 is equal to Z2 into Z1. How can we verify this? Just put the values Z1 into Z2. Z1 into Z2 we have seen it is A1 A2 minus B1 B2 plus I A1 B2 plus A2 B1. Right? I can change the order, so I get A2 A1 minus B2 B1 plus I times A2 B1 plus B2 A1. Now you see this is equal to Z2 Z1. This is equal to Z2 Z1. So it is very easy to verify any property. Similarly, you can verify associativity Z1 into Z2 into Z3 is equal to Z1 Z2 into. Okay, just try it. Now multiplicative identity. For additive identity we have seen it was 0 plus I times 0. For multiplicative identity we have 1. Now you will see that 1 is a real number, it is not a complex number. But 1 can be written in the form of complex number just by adding 1 plus 0 times I. So now this becomes a complex number. What we have to verify is Z into 1 is equal to Z is equal to Z is equal to 1 into Z. Right? So one part I will do, another one is for you to try. You can try. So Z into 1, I will take Z into 1. Z is A plus IB times 1 is 1 plus 0I. Now just use the formula A1 into A2, A1 into A2, A into 1 is 1, minus B1 into B2, B1 into B2 is 0, plus I times A1 into B2, A into 0 is 0, plus B1 into A2, B into 1 is B. So this gives you A plus IB, which is equal to Z. Similarly, you can verify for the second part. So the multiplicative identity is 1 plus 0 I. Now comes the part of multiplicative inverse. What we have to see is, can we find some number Z1, say I am telling you that this number is Z1, suppose, which is equal to Z1 into Z, which is equal to 1. We have to find inverse. इनवर्स का मतलब होता है कि आप अगर किसी नंबर में इनवर्स, किसी नंबर का इनवर्स फाइंड कर रहे हैं, तो आपको एक दूसरा ऐसा नंबर फाइंड करना है जिसका अगर आप मल्टीप्लाई करें, अगर मल्टीप्लिकेटिव इनवर्स है तो अगर आप मल्टीप्लाई करें फर्स्ट नंबर में तो आपको आइडेंटिटी मिल जाए. तो आपको क्या मिल जाए? आइडेंटिटी मिल जाए. So now what we have to do is we have to find this Z1. We have to find this Z1. So let's see how to find this Z1. So to find this Z1, maybe let's see, Z value of that is A plus IB, right? And let's say this Z1 is X plus IY, which we need to find. Just multiply it, and this is 1 plus 0y. Multiplication we get AX minus BY plus I times AY plus BX is equal to 1 plus 0y. Now what you have to do is just equate the imaginary and the real part. So on equating we get AX minus BY is equal to 1, and second we get AY plus BX is equal to 0. When you solve these equations, you will get X is equal to A upon A square plus B square, and Y is equal to minus B upon A square plus B square. Okay, these are linear equations. What you have to do is just take X or Y here. Okay, just find the value of X or Y here. So when you find, suppose I find the value of X. So AX is equal to 1 plus BY, X is equal to 1 plus BY by A. Just put this value in second equation. And solve. So you will get the value of y from here. Take this value of y and put it over here, then you will get the value of x. यहां से जो y की वैल्यू मिलेगी उसे यहां पर रख देंगे तो हमें क्या मिल जाएगी, x की वैल्यू मिल जाएगी. और जब आप इसे पूरा सॉल्व करते हैं तो आपको ये वैल्यूज मिलती है. ठीक है, तो हमारा नंबर क्या बनेगा फाइनली, a upon a square plus b square plus I times minus b upon a square plus b square. This is the multiplicative inverse of the number z. And the multiplicative inverse is represented by what should I say? It is represented by z inverse. So z inverse is equal to this part. Okay, so what we have got is z inverse is equal to real part of z upon sum of real and imaginary part, sum of squares of real and imaginary, plus iota times negative of imaginary part of z upon sum of real square of real part and square of imaginary part. Okay, so let's say we take an example. Suppose we take an example to find the inverse. Let z is equal to 2 plus 3i. Z is equal to 2 plus 3i. So a is equal to 2, b is equal to 3. What you have to find? You have to find z inverse, which is equal to x plus iy. Okay, so x is equal to a upon a square plus b square. A is 2 upon 2 square plus 3 square. 4 plus 9. 4 plus 9 is 13. 2 by 13. Right? Similarly for y is negative b upon a square plus b square. Negative b upon a square plus b square. 4 plus 9 again 13. So z inverse is equal to 2 by 13 plus I times minus 3 by 13. This is the value of inverse. Now we have to see, let me just clear the board and we'll see. Okay, now what we have to see is distributive. Actually it's distributive over addition. Distributive over addition means when we find z1 plus z2 into z3, it is equal to z1 z3 plus z2 z3. I have to distribute this function over addition, distribute this value or this multiplication over addition. Or also we can do z1 into z2 plus z3 is equal to z1 z2 plus z1 z3. Okay, so what I want to say is this distribution of multiplication over addition and this distribution of multiplication over addition. So distribution of multiplication over addition, either it is left or right, this doesn't matter. Why? Because multiplication is commutative and associative. Okay, multiplication follows commutativity and associativity. That is why distribution over left or right does not matter. Next is very important. Okay, I should say this is very important. Division of z. Division of z means we have to find 1 by z. What is 1 by z? Okay, it is very simple. 1 by z is nothing but z inverse. Okay, see, in inverse what we did was z into z inverse is equal to 1 is equal to z inverse into z. So when we have to find this z or z inverse, what we did, we find it using this formula. So if I put this z under here, then 1 by z is equal to z inverse. Right? अगर मैं इस z को डिवाइड में ले आऊंगा तो मेरे पास z इनवर्स क्या आ जाएगा, 1 by z. राइट? सो यहां पर बस वही है, डिवीजन ऑफ z क्या होता है, z इनवर्स इज इक्वल टू 1 by z. Let's see an example. Okay, where z1 is equal to 2 plus 3i, z2 is equal to 3 plus 2i. Say. Now what you have to do is find z1 by z2. Find z1 by z2. First find a multiplicative inverse of z2. That means z2 inverse. Why? The question is why. So this equation is equal to z1 into z2 inverse. See, This can be written as Z1 into 1 by Z2. And 1 by Z2 is Z2 inverse. 1 by Z is Z inverse. So 1 by Z2 is Z2 inverse. Z1 into Z2 inverse. Now we need to find Z2 inverse using this formula. For Z2, A is 3 upon 2 square plus 3 square, 9 plus 13, 9 plus 4, 13, plus minus of B yani minus of 2 upon 13 times 9. So this is your Z2 inverse. Now Z1 into Z2 inverse. Z1 is 2 plus 3i. Z2 inverse is 3 by 13 minus 2 by 13 times. This. Now what we will do? We will put formula of multiplication. A1 into A2 minus B1 into B2 plus I times A1 B2 plus B1 A2. Okay, now just try to solve it. What you will get is 2 into 3 by 13 is 6 by 13 minus B1 into B2, 2 by 13. But this is negative, right? This is negative, so negative, positive. Plus iota times A1 into B2, 2 to 4 minus 4 by 13 plus B1 into A2, 3, 9 by 13. So the answer is 6 by 13 plus 6 by 13 is 12 by 13 plus I times 9 minus 4 is 5 by 13. This is the answer. So you have seen that what simple, and I should say how much simple it is to find multiplicative inverse or any inverse, additive inverse, additive identity, multiplicative identity, etc. With this video we give rest to algebra of complex numbers. Okay, so algebra of complex number ends here. Next video we will see many more important topics like conjugate of complex numbers. Okay, one of the most important topic. So मिलते हैं अगले वीडियो में, तब तक के लिए थैंक यू फॉर वॉचिंग एंड कीप सपोर्टिंग.